Welcome to a new lesson of the course. In this lesson we are going to know how to use the SysTick timer. In this lesson you will use the SysTick timer to blink the LED D2. The SysTick timer is part of the ARM Cortex-M0+. It is a 24-bit timer and counts down from a value stored in the load register. On this animation, the value of the register load is 5. The counter is decremented every clock cycle. When the counter passes from 1 to 0, an interrupt raises. At the next clock cycle, the counter is reloaded with the value of the load register, that is 5, and continues counting down. And so on. Create a new project and give it the name SysTick. Open the file SysTick.c. You are going to use the LED D2 that is connected to PIO 013, so you include the defines for this pin as done in previous lessons. Select and delete the code created by default on every new project to include an infinite loop that does nothing. The next code added is to configure the GPIO 013 as digital output, same as in previous projects. Add an interrupt service routine to toggle the LED every time that the SysTick timer goes from 1 to 0. Finally, initialize SysTick timer with the function SysTickConfig. Later on in this lesson, you will see more in detail all we are doing. Build and debug the project. The LED D2 is blinking with a frequency of 5 Hz, 100 milliseconds on and 100 milliseconds off. A function called SysTick has been added to the file SysTick.c, and in its body the function GPIO port toggle is called to blink the LED D2. But where does this function come from? Let's go to the file startup.lpc804.c. Search for the word SysTick. The function is defined as weak. That means that you can, as already done, define it again in your code. As you can see in the structure GPFN vectors, it is at the position 15th. That corresponds to the function that will be executed when an interrupt of SysTick timer arrives. On the online documentation of the ARM processors, you can see the vector table. That is the structure that contains the addresses of the interrupt service routines, and at the position 15th is the SysTick timer interrupt. The implementation by default was an infinite loop doing nothing. And this is the implementation that overrides the default one, blinking the LED D2. The function SysTickConfig admits as parameter the number of clock cycles that will be loaded into the register load of the SysTick timer. Let's find out how much system core clock is. Let's go to the function board initBoot clocks. At the last line of the function board bootClockFRO 30M, you can see that the value of system core clock is 15 MB. That is the frequency the CPU Cortex-M0 Plus runs. So 15 MB divided by 10 will be passed to the function, that is the amount of clock cycles in 1 second divided by 10, that is 100 milliseconds. So you will have a SysTick interrupt every 100 milliseconds. Let's see what the function SysTick config does. The number of clock cycles that are received as parameter is loaded, -1, to the register load of the SysTick timer. With the function nVigSetPriority, you set the priority of the interrupt, but here it is not so important because there is only one interrupt. In the control register you configure the SysTick. Let's see what mean the fields that are set. These are the registers of the SysTick timer in the ARM documentation. The register syst_rvr contains the value load, also known as reload, that is the value reloaded to the timer when it reaches 0. Let's see the control register syst_csr. The bit clock source is set to 1, meaning that the clock that decrements the counter register is the system clock, the same clock as the CPU clock. The bit ticking to 1 means that when the counter reaches 0, an interrupt is generated. Finally, the bit enable has to be set to 1 to enable the operation of the timer.